So far with proofs, we have talked about our proof blocks, which we have used a lot over the past couple of weeks. And recently we introduced the idea of a paragraph proof, which we did by taking our proof blocks and simply turning them into sentences and paragraphs. So the last and most common type of geometric proof that you'll see, especially on the high stakes tests of the EOC and the PSAT and the SAT, are these two-column proofs. So two-column proofs are exactly what they sound like. They are proofs where we use two columns. The columns are listed at the top as statements, which are where we say the things that we know to be true, and the reasons, which are our reasons that we know that they're true. So take a second and look at the proof that I have on the screen. So you'll see this one looks a little bit different than ones we've talked about previously. Most of the ones that we've had have been ones that have had vertical angles that may have looked something like this, which I'm just sketching. You know, we'd have our vertical angles where they touched, or they might be two separate triangles like this, or we've had the ones that are the shared side in the middle. But the one that I've got on the screen now is really two triangles kind of put together, if you want to think about it that way. So I want you to look at what I've got here. We've got two triangles, so I'm going to draw them separately so you can see them. We've got the triangle here. That's our ADC. And we've got the other triangle here, which is our BCE. Those are the two triangles we're going to be proving congruent in order to prove that AD is congruent to BE. So this is kind of pulling back on our previous video of CPCTC. And what I've done is, instead of us building one from scratch, we have a fill-in-the-blank proof. So you'll see that we've got our given information here. You're told that AC is congruent to EC and that angle A is congruent to angle E. So I'm going to mark that on my triangles up here. So we've got this big side right here that's congruent to this side. Alright, so I'm going to mark these on the ones that are separated so you can see them a little better. So AC is congruent to EC. We also have the information that angle A is congruent. So angle A is congruent to angle E. So again, I'm going to mark that down here so you can see it. And that's all that we're actually given per se, but I want you to notice that we do have one other thing that's congruent. These two triangles are sharing a very important piece of information right here. Okay, so this is our first case where you have had a shared angle of two triangles. Both of these triangles have the same angle C, so we know that angle C is congruent to itself. So angle C is congruent to itself. So over here, where I've split them up, we can see that angle C is congruent to angle C. So looking at our blanks, you can see that we've got our given here. AC is congruent to EC, given. Angle A is congruent to angle E, given. And then we have these two blanks. This is where we have to put our angle C's are congruent to each other. Now remember, we have to use three letters. So to talk about this angle C, that would be angle ACD, and then that's congruent to angle ECB. So angle ECB. And how do we know that those are congruent? Well, what do we always use as our reason for saying that shared sides or shared angles are congruent? You should have this one memorized. The reflexive property. Remember, it's with an X. Reflexive property. Alright. So now we got two more blanks. Triangle ACD is congruent to triangle ECB, so we got to use one of our theorems to prove the two triangles are congruent. In this case, it's angle side angle. You can see angle side angle. So it's ASA. And then how do we know that AD is congruent to BE? Well, those are corresponding parts of congruent triangles. So it's CPCTC. Remember, congruent parts of congruent triangles are congruent. And that is our proof that has fully been filled in. So we're going to do one more real quick. Given a beautiful triangle over here on the left, we've got, this one is a shared side triangle. You can already look at it and see. We're given that ZX is a perpendicular bisector of WY, and we have to prove that WZ is congruent to YZ. So again, we've got our blanks. So what's the first thing we always put? We always do what we're given first. ZX is a perpendicular bisector of WY. So let's look at the triangle and figure out what we know is congruent. Well, we know that ZX is a perpendicular bisector, so that means it's going to be creating 90-degree angles here. Okay, and we also know that it's bisecting WY, so these two are congruent, and we have our shared side. So for our first blank, it says we know something based on the definition of perpendicular, so that would be that angle ZXY is congruent to angle ZXW. Alright, then our next one, we're given, our statement is WX is congruent to YX. How did we know that was true? That was by the definition of a bisector. So that's by definition of bisecting, or definition of a bisector. And then we got another piece of information that we have to figure out. What is the other thing that we know is congruent? That's our shared side. ZX is congruent to ZX, and we know our reason for that is the reflexive property. And then this one, we don't have any blanks. Triangle WZX is congruent to triangle YZX by the SAS postulate. And then we know that WZ is congruent to YZ by CPCTC, because congruent parts of congruent triangles are congruent. So now go and answer the questions that go along with the video.